Welcome, guys, Manic podcast with my guest, Steve Snyder. He is my uncle. How are you today?
Good. How are you doing?
Good. So, describe your job for me. I don't know how to properly describe it. I always knew as a kid, kind of. You used to work at the Franklin Institute Museum, and that was like my favorite place to go to as a kid. So, what did you do there first?
Oh, what I do there. So, I'm a scientist in a former life.
Yeah.
And I've spent the last, 25, 30 years working in science museums.
Yeah.
It's a science center. So the Franklin Institute's a science center. While I was there, I oversaw exhibits and programs and all sorts of different kind of projects that we did that tried to connect people to science and do all sorts of cool stuff like that. So I'd spent a lot of time working with our internal team on creating new exhibits, whether it's about the brain or about trains or about airplanes or any of that kind of good stuff. I spent time going out trying to find cool exhibits to bring in. Whether it was from China or Russia or anywhere in the world. And then we also created, programs, new kind of programs that we could do, a science festival. We did a number of programs, camps and overnights and all that kind of good stuff. Really any way we could get people to sit down and talk to us about science.
Yeah. So it was purely science what you worked with? Because I remember the King Tut Museum and stuff like that.
Right.
But you guys did have the historical stuff that you worked on.
Well, yeah. So we also had a collection, but mostly a scientific collection. So the Franklin Institute's a science museum, so it has a scientific collection of all sorts of devices, patents, crazy ideas people came up with, and patent models. Perpetual motion machines, things that would never work, including all sort of cool discoveries that were made as well. We had the Wright Brothers collection. So this is what the Wright Brothers used to figure out how to build the first planes. Their scientific collection was us, including like scraps of notes written by them on the back of wallpaper. Mm-hmm. So they were so poor that when they needed paper, they just pulled the wallpaper off the wall and wrote on the back of that to make their notes. So all kind of cool stuff like that. And then a lot of the exhibits we brought in were things that we didn't have. Obviously we don't have King Tut's collection.
Yeah, of course.
It's in Egypt.
Yeah.
So, we'd work with companies who would be touring it, and we'd bring that to Philadelphia, whether it was King Tut or Cleopatra or the Titanic, or a whole host of other different kind of exhibitions in that way.
Oh my God! So did you travel to those countries to bring them in?
It depends. So in some cases they were tours already put together. In other cases we were going to try and set things up. So I spent some time in China trying to get a tour put together for the Terracotta Warriors. We looked at maybe developing an exhibit around the Great Wall of China. We went to Russia to try and figure out an exhibit that never came together, but was a bizarre trip in and of itself.
Yeah.
So lots of different opportunities to travel places and do things. We spent some time in Jerusalem working with the Science Center there about maybe co-creating an exhibition. So lots of different things.
So now that you're working at a new museum in San Diego, I know that. What is your job there now?
Now I'm the president and CEO. So basically, it's my fault. Whatever happens, it's my fault. That's kind of the way I put it. And I get to do what's cool about my job now is I get to get my hands into a lot of things, a lot of different things. So, one morning I might be working with our marketing group of figuring out what's our messaging going to be about, us reopening. In the afternoon, we might be talking about an exhibition. Then we might be talking about a program. Then we might be talking about our financial situation. So I get to do a lot of different kind of things, from accounting all the way to exhibit development and sort of everything in between.
So you have like all the responsibility now.
Overseeing
things.
Yes, yeah, in the sense that there are people who actually are experts in each of these things and they do them.
Yeah.
So, yeah, but at the end of the day, like I say, it's my fault. It's my job to make sure that they can do their work, that they can be successful in what they do, and that it all comes together in a way that makes sense for the organization.
And it's so odd to because I think about college all the time, and like I have a lot of friends who are in college and they have their degree, they go in that field and that's it. You're a physicist, right?
Right.
Is that
Yeah.
So how did physicists transfer to museums?
So I love science. That's why I'm in a science center. It's still there, not just another kind of museum. I got into science centers sort of through dumb luck. Well, I'll tell you two stories. The dumb luck story was when I was finishing up my graduate degree. I was looking for my job, right? What's going to happen?
Yeah.
I'm going to get my PhD, and then you got to get a real job. Okay, now what? I've been at school since I was 5 years old. I'm now 26. Now what am I going to do? And so I had literally been applying to lots of different places. I actually had what looked like a faculty position at a university lined up. They hadn't made the offer, but I heard they were going to make me the offer. I hadn't accepted, but that was lined up. And I was in my lab one day, and I saw in this newspaper, because that's where you looked for jobs in those days, this called Chronicle of Higher Education, this job posting for a museum in Kansas City who was looking to build a science center and wanted a scientist. Yeah. And I said, oh, that would have been a weird kind of thing to do for a little while. And I looked over, and I literally had one vita, which is a professional way of a scientific way of saying a resume, one envelope and one stamp left, literally. Because in those days, that's what you had to do. You printed things out and you mailed them to people.
It's a lot different now.
Very, very different. That's the way you did it. And so I said, well, what the heck? So I just sent it off, and they called maybe a week or two later and said, you want to have a phone interview? Sure. So I did the phone interview. I got back to the lab. People in the lab said, well, how'd it go? And I said, oh, it was crazy. They're nuts. They hated me. I didn't think what they're doing is interesting. Onward into academia. and then they called another week later and said, you want to come down for an interview? I said, hey, I'm a graduate student. I don't travel anywhere. I've never been to Kansas City. It'll be fun. I'll just do the interview. And I went down for the interview. They offered me the job. I thought this would be a cool thing to do. They kind of got this the second largest train station in the country, turn it over into a science museum. I thought, well, why not? I'll do that for a couple of years. And I did. I just never went back. I just never came back. I kind of fell in love with it. And really it was because, I got to do, so doing science is fascinating, it's exciting, but I learned early on that I loved talking about science and kind of sharing the experience of science. What gets me excited about it with other people. And so I loved teaching. When I was a graduate student, I loved being a TA. I loved teaching. I helped start an organization where we took experiments and stuff out to kids, all this kind of stuff, really just to get people excited by it. And now here's something that was a job that would let me do that and pay me to do that. Awesome. So that was really sort of the shift. And then from there, I just stayed in the field.
Really? So it's a cooler way, and it's not just teaching what you do. I remember as a kid, we went to the Franklin Institute, and then there was it was like grossology. I think that's what it was. It was the coolest thing in the world.
Right.
So you're bringing knowledge through to ways to people who, whenever, I feel like there's a stigma to science when you're a kid of, oh, this is this is uncool. You don't, but when you really, not dumb it down, but make it exciting, and show them this is cool, this is fun, like realizing that the world isn't just, ABC. It's like, well, this is what makes it ABC.
Right. And that's the exciting thing about science, right? It's not that, okay, I'm going to play baseball. I'm going to figure out the curves, and then here's where things. No, that's not that's not what it is. The exciting thing about science is it lets you see the world in ways that other people can't. There's this great line in Blade Runner at the end where the lead villain is about to die and says, I've seen things you people wouldn't believe. And science lets you do that all the frickin' time.
Yeah.
Right? It's not just, well, I know things. Yes, but that knowing things lets you understand things in a different way. So I'll share this story with you. That's a good example of this, and it features your grandfather very heavily. Okay? So when I was 12 or 13, I had a paper route. So for those of you who don't know what a paper route was, that was kids used to get a couple of bucks to take papers and drive them around, on their bicycle and ride them around and drop them off in places. And so I had, you'd go and you'd do this both, uphill both ways, quite literally kind of thing, dragging these papers around, and you deliver them, you get some money. And after a while, I'd built up a bit of money, and my dad asked me, so what are you going to do with that? And I thought, oh, geez, what am I going to do with this? I guess I've got money now. I lived in suburbia at a time when there was no online purchasing. There was none of that, right? If you wanted something, you got on your bike and you rode 3 miles, and maybe you could get a candy bar. Woohoo! So I had a fair amount of money. And I said, well, what I really would like, I'd love a telescope, a really good telescope. So, my father, Grandpa was like, right? He heard that, said, all right, he needs to research this.
Yeah.
Now he was not necessarily a science guy. He worked in engineering, worked in computers all his life. He loved watching the nature shows, but he wasn't like a big into science kind of guy. But he went to the library, pulled out the microfiche, pulled articles, researched everything you could about how, where, what, how do you buy a telescope, right? To make sure we buy it right. We're going to buy a telescope, we're going to do it right. And so he collects all this information. He talks to people he works with. He makes phone calls because you had to in that day, right? He had to make a phone call, use this phone book to find where people were. And he pulled this information together. And one day after dinner, he says, okay, so I've looked at all this up, and it says, one of the things we should do is we need to go see an amateur astronomy group because they can help you figure out what kind of telescope. They might have a used one for sale, yada, yada, yada. And he found one like halfway across the state. So after dinner, on a school night, we get in the car and we drive all the way out to this observatory where the Amateur Astronomers Inc. of New Jersey were having their meeting. And they have a meeting, some business meeting, which is kind of boring, and someone shows a slideshow. And then they say, okay, so now we're going to do some observing, and they go up to the telescope. Okay, this is a 26-inch reflecting telescope. This is a massive telescope. The only telescope I had ever seen before was the toy one I have. It's about 1 inch in diameter. It's a metal tube. Here's this amazing thing. And say, okay, we're going to look at the Ring Nebula. Okay, so, all right, science lesson. And here's the difference, right? So this is, and it's an important piece. So the Ring Nebula is what's called a planetary nebula. It's got nothing to do with planets, but it's what happens to stars like our sun at the end of their life. So a star normally is this battle of two forces, right? Stars are massive, massive, massive. You know, like there's I think 330,000 times the mass of the Earth is the mass of the sun.
Wow.
And all that mass is a lot of gravity, and it crushes the star. It's trying to crush the star into as small a space as possible. So as it crushes all this hydrogen, which is most what the star is about, in the center, it gets denser and denser and denser. And the denser you make something, the hotter it gets. The more you squeeze it together, the hotter it gets. And it gets so hot eventually that hydrogen atoms start colliding with each other with such force that they fuse and turn into helium. And when they fuse and turn into helium, they release an enormous amount of extra energy, which heats up the core more, which means more hydrogen atoms start colliding, releasing more energy. And you start this fusion reaction, this chain fusion reaction, which basically creates, if you will, a nuclear bomb, a fusion reaction bomb in the center of the star that's trying to blow it apart.
Wow.
So you get these two forces, the gravity trying to crush it and the force of the core of these explosions trying to blow it apart. And right now, luckily, our sun is balanced. Nothing's going on.
Thank God on that.
Right, which is all good.
Yeah.
So we got this wonderful sun that does so much for us. But eventually, the star uses up most of the hydrogen inside the core. And then it can't create as much fusion reaction to support the gravity, and gravity starts to crush the core. Yeah. It starts to crush it. Of course, as it crushes, it gets hotter and hotter. And eventually it gets hot enough to start a new kind of burning, a new kind of reaction with hydrogen and helium together, and helium and all sorts of other. It gets really complicated quick. And that starts a new kind of fusion reaction. And it gets complicated. It's about shells and all sorts of other things. But basically what happens at some point is that this crushing of gravity starts this new kind of fusion reaction that actually causes the star to grow. It starts beating gravity, and it grows and grows and grows and grows and grows and grows. When I say it grows, when our star hits that point, it will grow to engulf the Earth and possibly even Mars. It becomes this red supergiant. And you can actually see a red supergiant. If you ever look at Orion, Orion's shoulder, the high shoulder, is this red star called Betelgeuse, which is a red giant star. If you put that in place of our sun, it would go all the way out between Mars and Jupiter.
That big?
That big.
Oh
Hundreds of millions of miles in diameter. So it's this huge, huge space that it gets out there. It gets bigger and bigger and bigger. Meanwhile, at the core, the core is also, so eventually it gets to a point where it can't get any bigger, and gravity starts squeezing the core again. The problem is there's not enough material left because it's gotten so big at the core to start a new set of fusion reactions. It gets hotter and hotter, but it can't fuse anymore. So all that material that's been expanded outside the star, the gravity's too weak now to hold it in, just starts drifting away. And what you're left is at the center of this star is this core, eventually that blows off all the material around it. This just sort of burning ember of a star. That's all that's left. Tiny, dense, very, very hot, but no longer fusion reactions, and hundreds of millions of miles of debris. This 200 million miles probably in diameter gas field. The cool thing is, because that star is still hot, it's still glowing. And the radiation that comes off of it hits these gas particles, this debris, this giant debris field, and causes them to glow in reds and greens and blues. And so what you get is a planetary nebula. It's this giant, massive gas field, glowing gas field with this tiny dead ember of a star at the center. And that's what the Ring Nebula is. Yeah. So I'm now looking through this telescope, and there it is. There's that tiny dead ember of the star. There's this hundreds of millions of miles of glowing gas that's the result of fusion reactions at the center of the star that creates all sorts of cool stuff. And I'm just like in awe. This is just so cool. And eventually I hear, right, time for me to move out of the way. So I pull myself away from the telescope. I move to the side. And my dad, your grandfather, leans down, and Grandpa was tall. He's a big guy.
Yeah.
He's a tall guy, 6'4" or something. So he bends all the way down to look at this. He looks through the telescope eyepiece, and then looks up and looks past the telescope into the sky, right? As if he's going to say, "Look, what?" And looks down at this thing. He 2 seconds. He walks over to me and goes, "What?" It was a fuzzy dot with another dot in the middle of it. Like, oh, no, it's, fusion reactions and pulses and hydrogen burning and equilibrium equations. And tiny dot with a fuzzy dot in the middle. That's what he saw. Now, the thing is, when you look through a telescope from the Earth at the Ring Nebula, what you see is a fuzzy dot with a dot in the center. That's what he saw. That's what you would see if you look at it. I saw all the rest of it, right? Because I read about it, I knew about it, I had a picture and a model of what that was, and I could see what that fuzzy dot meant. I could see all these different things happening in this dot, from the shape of it to the colors, all those things. Well, it's not even colors, but the way of looking at it. And so I could see something completely different than he did. And that's the cool thing about science. And the cool thing I realized later is, right, so there's Grandpa, on a school night doing all this research, driving me out to this place to look at a fuzzy dot.
Yeah.
Right? And he's not getting it. But that was such an enormous gift, right? Because even though it was something he didn't understand, doing that meant this is something of value, that this was worth his time to do, even though he didn't necessarily get it. And that was huge for me, right? It's a huge, huge thing to see. I get a parent taking that kind of interest and putting that effort into something that they don't get. And that's sort of that creates that sense of, oh, this is something worthwhile. It's meaningful. It's not just some trivial thing. Because he could have said, okay, it's a fuzzy dot. This is stupid. Don't do this no more.
Yeah, makes no sense.
He didn't, right? It doesn't. But for me, he saw the interest I had in it, and he supported that, and that really, made a huge difference in the kind of trajectory that I took. So making the shift from science to helping people have those experiences, seeing those fuzzy dots for the amazing things that they are, and encouraging folks who have that passion to go into that, that's just an awesome thing. That's sort of the big shift that I made.
I could totally see, like you said, there are people right now, I feel like it's unlocking that way of thinking, or at least opening your eyes. I mean, to Grandpa, it was a fuzzy dot, but like you said, you're seeing the same thing, but you're seeing what it is. So if you teach these people what that is, it opens up that whole area of your brain. It's
right.
It's amazing.
Well, that's the thing, right? We miss so much because we don't know what we're seeing. You don't know what you're missing, right? You don't know what you're missing when you don't see something, when you don't have the context for it. It's like it's like art museums. I have to admit, we don't spend a lot of time in art museums.
No.
I'm sure. I know. Greg told me about a trip you all took. I don't know if you took, but I know Emma took to the
Guggenheim.
To the Guggenheim, right? And walking out, going, "What the hell was that?"
That was
right?
such a confusing.
Like, what in the world were we looking at? So my wife and I did that years and years ago. We were at a conference and we went to the Guggenheim, and they were having a show called "Abstraction in the 20th Century." We didn't know. I'd never been there. I grew up here. We'd never been to the Guggenheim. And Guggenheim's got this big ramp.
Yeah.
Right. And of course, we didn't know that you're really supposed to take an elevator to the top and walk down the ramp.
I didn't even know that.
So that's the way the building was designed. So we walked up the ramp, and it's this, okay, so there's some Kandinsky paintings, which we kind of knew about. And then there are things like a broken chair. There's a TV with the vertical hold broken.
Yeah.
Right? These things where you're kind of like, what in the world? Just one thing after another. We're just like, what in the world? And we get to the pièce de résistance for us. We got to this art piece that was someone had piled bricks, like just gray bricks, and stacked them the way you might stack them on a job site.
Yeah.
Right? And next to the sign, this is how we remember it, it says the artist's name and pile of bricks, reproduction. It wasn't the original pile of bricks. You need to be careful. This was a reproduction of the original pile of bricks, but it was pile of bricks. And so we used to laugh the heck about that. I mean, pile of bricks, this is an art piece. But a bunch of years later, I was thinking about it, and I said, this is, and when Google, or not even Google at that point, when the web was really available, I said, I wonder what that show was, and who was the artist who created Pile of Bricks?
Yeah. And
I found the catalog online for the show. And it wasn't called Pile of Bricks. It was like Equivalence Number 4 or something like that. Clearly much more indicative, by Carl Andre. I'm like, what in the world? And then I start reading about what it is, what was going on at the time, why they were doing this. And suddenly this context clicks for me, right? This pile of bricks is a pile of bricks, but in a certain context, understanding the rules around it, what was being said or done, why this mattered at the time. You suddenly begin to understand why people can see something more in this pile of bricks than I was seeing. And it's the same thing with science. We spend so much time that we miss because, we dismiss things. That's ridiculous. But if we take the time to understand, we see wonders in a pile of bricks or a fuzzy dot, right?
Yeah, of course.
That's cool.
Of course. You could say the same thing about, I forgot what my teacher once said. It was something about gravity. It's like you can't see it, but it's there.
Right.
It's
Right.
you showed somebody back, 100 years ago, 200 years ago, or whatever, before they knew about it, you could just say, look, this is gravity. What am I looking at? Gravity.
Right.
It's gravity.
Well, right. That's the thing. And so the idea, right? So people knew about gravity all the time. People have always known about gravity.
Yeah.
From the first time you got up and fell over, you knew about gravity. No one had to discover it. Newton didn't discover gravity, but Newton thought about it and said, okay, well, what if? What if gravity extends? Okay, we know gravity extends to the top of my head, and it extends to the apple on the tree. And if I put that apple on top of a mountain and it fell, gravity would extend out there. So what happens would gravity reach all the way to the moon? Right? And with just that thought, suddenly our universe changes, right? He creates these laws of gravity and motion and all these things from this thought experiment of something that everyone knew was there. When you drop something, it falls. And thinking about it, and now, again, the motion of the stars and planets became understandable, or we knew why they were happening, and we could predict them in such great ways because someone thought, okay, gravity, this thing that everyone knows and can't see, what is it? How do I take that fuzzy dot that's gravity and make it into something more? And that's good. That's freaking awesome.
It's insane to really think about how much we don't know and how much we don't see.
Yep.
Like there are so many. Whenever I talk to somebody, even about I always think about the human body, and we think about how much we think we know, and then I talk about the brain, and I've talked to so many scientists about the brain, and they're like, everything we know, we at the same time don't completely understand, and it's so confusing to me that ourselves, like as people, as humans, we don't even know ourselves.
Right. Oh yeah.
Fully.
Oh sure. And brain science is and neuroscience and all the research going on there is so cool. But this is the thing. We are studying ourselves. We're using our brains to study our brains.
It's so
that's okay. Very meta, right?
Yeah,
it very is. And that's the challenge with it. But that's what's so cool. I mean, that they're learning such things about how our brains work and what does and what doesn't happen. And the fact that to me, it's like neuroscience is waiting for its Galileo moment, the moment where everything shifts. And what it could shift would change everything, right?
Yeah.
The way we think about ourselves, our relationships, crime, punishment, all sorts of stuff as we get a better understanding of how our brains work and what's really involved. So it's enormously cool, and some of the work people are doing is just amazing, just incredible.
And it's hard for me to think because, again, I'm not in that field or anything like that. It's hard for me to think, okay, how do you even start? Like, how do you look for something you don't know? Right. Do you, as somebody who's been and understood stuff like this, how would you go about finding, a discovery or if you could come up with an example of anything, how do you start to find something that you don't even know exists? Like, how did they find out about what you were talking about with the planets or the colors of the sun? How did they figure out, like, oh, this happened?
Right. Well, yeah, and so it's basically a process. So this is the other thing about science that most people don't think about, right? So there's two visions I think people have about science. It's like you get your PhD, right? And they give you a copy of the big book of science, and your research is finding the answer in the book. No. Or that you walk out one day and say, I know, I will discover this. Doesn't quite work that way. Most science is built on other science. So someone is doing an experiment and sees something weird. There's a great line, I'm forgetting who it is, from Isaac Asimov, that the most exciting words in science, and I'm going to mangle the quote, is not eureka. It's, that's odd, right? They see something that's different, that's unexpected. Well, what could cause that? That means there's a question we don't know. I didn't expect this to happen. That's the most exciting thing.
Yeah.
Right? It's not that, oh, we found the next answer, or we further understood it. It's finding something that no one expected. No one thought this would happen. And a lot of what happens when those things are happening is in some cases it's a new technology that lets people see something. It's a new experiment, a way of thinking about it, and data comes out that doesn't fit the model. People like to say, oh, scientists, they're hiding things, or no, it's not, because if they just don't want to know, they don't want to change, right?
Yeah.
Oh yes, that's where Nobel Prizes come from.
Yeah.
They don't come from stuff that they know. It comes from the stuff we don't know. So That's the exciting thing is that oftentimes people find something weird in an experiment. They go and then research that and figure out what's going on.
Yeah.
And oftentimes you get a whole new field that opens up, that you discover a whole new area of research to go into, a whole new set of phenomena, and then you build on that. You know, a lot of scientists spend a lot of time reading papers of other people's experiments because you're looking at that stuff to say, well, is it really right? Is it true? Because a lot of experiments, you know, look perfectly okay, and then it turns out they didn't quite work when we do more research, or there's an interesting question, or it sets up what happens next. What more do we need to know? So it's really kind of a mix of things that happens from all different kind of directions.
God, that's so being a scientist there's so many different ways of going about science. And you know, as a kid, you know, you're taught the scientific method. Is that your like golden standard, or is that just something they teach you as a baseline?
You know, so the scientific method,
Yeah.
right, is kind of a misnomer, and it's a useful teaching tool. But scientists use a number of methods and tools. And to me, the thing is, science's biggest and most powerful thing is its ability to tell us when we're wrong, not when we're right. Science is most exciting when it says, you thought it was this, but guess what? It's not. That's the coolest piece, right? And it shows us we're wrong. Because humans are pattern-seeking animals. We seek at patterns everywhere, right? That's why you look at your toast and, oh my goodness, look! It's Bill Cosby in my toast. What's he doing there? No. You see these patterns, right, all the time in things that you would never expect because our brains look for patterns. That means we often see patterns where there aren't, and we ascribe power to patterns where they aren't ones. And so science is a set of tools that lets us really look at these things and say what's real and what's wishful thinking, or what's something that our brains are being sloppy about.
Yeah.
And so it teaches us what's right and wrong, or it shows us a way to do right and wrong. And there's a whole bunch of different techniques. So the scientific method is certainly a way of thinking about it, but there are lots of methods that people use.
Of course.
Lots of methods. Well, astronomers don't do a whole lot of experiments because you really can't say, what would happen if I twisted, if I bumped this planet out of its orbit? And so, no, we can't do that. So they don't use sort of the standard what you see. A lot of things that aren't using those standard techniques, but there's a whole set of tools, a whole set of different tools.
And there's a lot of situations where, you know, you have to base your experiments on, what am I trying to say? Not probability, but you're basing it off of the what is it? The law? Is it the laws of physics and stuff like that? Like how a planet would do this and that. And,
right. We expect this to happen.
Here's exactly.
Right. So
Something
science
like
is
that.
about building models. You build a model for how it works. Okay. And a model is, it's a mental construct. It's a thing we come up with to explain what we're seeing. And if the model works in multiple situations and it makes predictions for things we haven't seen that we then look for and find, that tells you the model's pretty good. And we like to keep them on we keep them around. And eventually, so you create a model, it works. If it holds up to multiple different kinds of streams of data and experiments, it might become what's called a scientific theory, right? When scientists use the word theory, it's different than the way we use it in common speech. Well, I have a theory that the next roll of that dice is good. That's not a theory. That's an idea.
Yeah.
Right. Scientific theory means it's a model that has been tested and tested and tested and is held up to enormous scrutiny and has enormous predictive ability that's been proven right. So it's a very different kind of thing from the theory that we normally see. And those are the kind of really exciting things that kind of help us determine how things work.
As a scientist, this is a question I think about a lot whenever I hear about studies and stuff like that. And I've met people who are, kind of scientists, stuff like that. And one question that they always look at me a little funny at when I ask, is any answer solid? Like that's the answer. Because at the same time, I'm thinking, I'm like, well, didn't we used to think like the sun revolved around us and stuff?
Right. Yeah, that's you're absolutely right. So if you're really looking at this, the idea of science, right, is it the answer? It's the best answer we have right now.
Okay.
And that answer is proven in many cases, so right. Right? How many times can a thing be right before you really think, okay, it's probably right the next time too?
Yeah.
That we really can depend on it. But science always holds the door open until data says otherwise, until something else comes along and says, wow, that doesn't fit. Okay, that means something's got to change. And and so there was again, in the late 1800s, early 1900s, people were trying to understand how light happened, right? Because everything we know happens in a medium, waves in a medium, air is a medium. And so they created this notion that there's this thing called the ether, E-A-T-H-E-R, the ether that permeated everything. And light was a wave traveling in the ether, this field we couldn't see. And it had all sorts of rules. And so then what they want, this group, Michelson, Morley, these two scientists set up an experiment to try and see and test this ether theory and test how waves moved in it. And it turned out in this experiment that no matter what they did, no matter how they looked at things, the speed of light was always constant. And in the theory of ether, it shouldn't have been. Something was fundamentally wrong. Huge, important experiment because it actually turned, that's sort of a big turning point in the world. But that experiment and others basically said, okay, this ether theory, which had been working, it doesn't fit all the data. There's new data that says this isn't right. We need to go back and rethink it. And ether theory is gone. It's completely gone.
Really? So something that was there, we
thought it was there. It just did this model worked until it didn't. And when it didn't, it meant we had to change it. And this is true all the time. So, Newton, right? Newton's laws.
Yeah.
Newton's laws were right until Einstein came along and said, yeah, but right? There's a space where that doesn't quite work anymore. And so it needed to change. Didn't mean that Newton didn't get thrown away. It turns out that Newton wasn't the full story, that at certain speeds, Newton needed to be modified, and there was a more general way of doing it. So theories often, scientific models and theories often expand as new data comes in. In some cases, you've got to throw the old one out because it turns out we didn't have all the data and something was wrong. And that's the thing why, and it gets into all sorts of problems when you start talking about politics because everyone wants science to be definitive. And science is definitive to a point, but we're always saying, yes, unless something else comes up.
The door is always open.
Right, we have to be because science's biggest power is to show us when we're wrong. And if we're not willing to admit we're wrong, we all know it gets...
Then it gets messy.
Right, everything gets messy, not just in science, but everything.
Of course.
Right? So science is kind of set up in that way and that's why again this notion of people are saying because the establishment of science doesn't want these new theories to happen. Well, if you're a young scientist, you want to break the old theory down because that's how you're going to make your space in this. And so it is. It's very it can be very aggressive in that way. And people come up with theories and they put ideas and models and they put them out there and people shoot them down and it's all, we say it's all in good fun, but in a sense it is. It's all really in trying to figure out what are the ideas and models that really work.
As a young scientist, you're saying you're trying to, break out. In the society we live in now and how it's so technologically advanced, do you think that it's harder now to make discoveries than it was when Galileo was around? Or is it the same situation of we think we're so advanced, we're not? I mean...
Oh, sure. So so Lord Kelvin has a whole temperature scale named after him. Did all sorts of work in thermodynamics. Brilliant scientist. He said, and again, forgetting when his time was, late 1800s, early 1900s, he said, in 20 years, science will be done. We'll know everything there is to know. We'll have it all worked out. Right. Nature throws you another loop. So it's exciting really at any time. And right now there's so many things. You're talking about neuroscience or biotechnology and biosciences that are going on that we're understanding. New technologies mean things that mean you're able to do and explore things you never could before because they're experiments you could do. So genomic sequencing, right? It was still only, forgetting now it was, in the late 90s that we first sequenced the human genome, right? And that took 10 years. And now you can sequence someone's genome in a matter of, an hour and a half.
Yeah.
And for so much less expensive. That means there's a whole bunch of experiments that could be done that never could be done before. And that means there's new things to explore, new things to discover, new things to understand. So it's really, it's a wide open kind of thing and very, very, very exciting.
And it seems very hard in certain situations with science and that, science is very pure. And I feel like human morality comes in sometimes where you can't do certain things. And it's so hard to, figure out. And one of the things that I thought was really interesting, horrible people, horrible situation, Nazi doctors. I remember talking to a psychologist once, and they were telling me we learned so much because of these horrible people. And I think about science is the most pure thing that humans have, based off the fact that it's just discovery. It's using things and discovering amazing things. And at the end of the day, horrible situation, but at least we could learn from what happened.
There's so this is the thing, right? So the idea of pure science, right? Science is still done by humans. Right?
That's
so at the end of the day, we need to remember that, right? These ideas and tools that we've built are to keep us from fooling ourselves, right? So that's what these tools really do in many ways. They keep us from fooling ourselves and lead us to new understandings, right? And ways to do this, which is very, very powerful. But humans still apply them.
Yeah.
Right. And the sad thing is we know what's good and how to be good to each other.
Yeah.
Yet somehow we always find a way how not to. So there's a whole field in science, in ethics, in scientific ethics. Should we do this experiment? How do you do it in an ethical way? What are the outcomes of it and the implications of this? Particularly, we were talking about neuroscience earlier. I mean, think about what this could mean. I mean, if a new understanding of how our brains work and how we're driven and how the models work could change the way we think about law, relationships, everything. So you can't just say, "Oh, here's a new understanding. Good luck with that."
Yeah.
You really need to think through, and there are ethicists and programs in universities, and to really think through what does this mean.
Yeah.
Right? What's an appropriate and right way to move the research forward? We want to understand more, but we want to do it in a way that is ethical, that's not harming and hurting. And there's all sorts of discussions about where those lines are drawn and where they're not. But it is something that has to be the case because we're still humans.
Of course. I mean, we don't want to hurt each other. We don't want to do anything that's going to damage another person, but we do want to figure it out because it will help us eventually.
Right.
I mean, it has
right.
to.
And those are questions that people need to be thinking of and scientists think about as well. And that's the other thing too, is that the public needs to think about, right? Science shouldn't be something that happens with special people doing special things in special places, right? That does create new discoveries. But science is something everyone has a stake in. So how does the public become part of that, right? That's a lot of the stuff we talk about at the Science Center. I'll start talking about public engagement in science is how do you engage people in the scientific endeavor? How do you engage everybody in it? And how do people use those tools in their own lives, right? I mean, again, obviously with COVID, there's a lot of opportunity here for people to be thinking scientifically. But we don't.
Yeah.
We just tend not to, right? And so how do we help people? And that's, like I say, that's my job now. Is really how do we help people learn what these tools are, think about them in ways that they can apply them to their own lives. And then in being able to do that, be able to have a bigger stake in talking about, well, what are the questions we really need answered, right? Scientists can pick questions and that's great, but the public should have, here's what we're wondering about. If we could understand how this happens, we could make huge changes. So how do we make the public part of this conversation?
That would be a cool exhibit one day, whenever all this pandemic stuff, like a COVID exhibit. If you imagine that, like one of the coolest things that I saw recently, I used to play World of Warcraft a lot. Yeah. And there was a time, I guess what happened is there was a bug in the game where you go to a dungeon and they caught something like a debuff that damages you over time. Yeah. Apparently it got out of the dungeon into the world and it spread like a pandemic. And they use that in science to show like what happened. And you think about COVID, for me, COVID, the situation we're in right now is misinformation. You have so many different news outlets saying this and that, and no one's listening to the science aspect or the people who are, looking at it from, okay, well, this needs to be taken care of and this will do this. My girlfriend was talking about how she was scared at one point of infertility from the shot. But then you start to I talked to some people who know about chemicals and all these things. And it's like, listen, people get scared of the unknown and they start to make up things that, well, this could do this could do this, that we don't know anything about this. But at a certain point, you need to learn to control what's going around because this is like, it's ethics. And you also do need to, not just take a risk and say, whatever, guys, this is what's happening. We're going to just give you a shot and hope that it works. Right. That's not what we're going to do. We need to say, okay, well, I believe the COVID shot is a variation of another shot. I think that's what I heard or something along those lines. So it's not like it's brand new. It's based off of an old one that we're working on, and it's really scary with a pandemic. How has that affected, your workplace? I mean, it had to have at some point, right?
Oh, sure. I mean, we were shut down for a year.
Yeah, really.
It really was, and really, and again, a lot of what we do is really, as a nonprofit, we're focused on what does the community need us to be and need us to do.
What's the museum called, by the way?
So it's the Fleet Science Center
in
San Diego.
Yeah.
And so we really are, and so that's the museum, but we're really a countywide organization that operates a science center. We also do all these community-based programs. And so really when the outbreak first happened, it was clear people didn't need a science center to come to. They would have liked to, but they weren't. Of course. It wasn't where the need was. So we needed to shift. Where was the opportunity, right? What kind of digital content can we provide that people really needed? When schools didn't reopen and when people were going digital learning, we had all sorts of kids who were, if you were a first grade child of a first responder, how is school going to work? What are they going to do? Are they not going into the hospital and saving those lives, or leaving you at home alone if you didn't have it? So we created space for the kids to come in and they could do their online learning in our space.
Oh, wow.
Separated out with hyper cleaning and with folks who could help them with what they were doing. So it really was about shifting our attention to what did people need us to be during that time. And so that really was the big push. And then after a while, it was also questions like, okay, when the vaccine came out, let's get people in front of the experts to ask them the questions they want to ask. Not the news media, not this push, right? This is the biggest problem we have in my mind is that, all media is push. Even if you're having an argument in the comments section, right? You're not having a discussion with someone. You're pushing at each other. I'm going to throw this at you. I'm going to throw this at you. You don't do back and forth. So how do we create opportunities for people to talk to scientists who are not working for the pharmaceutical companies, or not working for this, or not, who are just looking, saying, here's where it is. Here's what we know. Here's what we understand. Here's how it happened. It's one of those things where, again, early on, oh my gosh, they created this in this amount of time. That's a marvel, but it's not a marvel we didn't think could come. They've been working on mRNA vaccines for 40 years, right? There's a lot of work that happened beforehand. When people started experimenting with the vaccine, right? The quickest vaccine before this had been something like 4 years to develop. But that's because there were a couple of groups doing it. There were over 200 vaccine candidates by April of the year when COVID first emerged, by 2020, that were immediately put into experimentation. Okay, we've gotten 5 if you count the Sinovacs, out of hundreds of experiments. Most fail. Most didn't happen, didn't work, didn't get all the way through. So normally, if you have maybe a dozen groups working on something and you've got that kind of success rate, it's going to take a long time for them to find success. But if you've got a lot of people working all, at the same time in parallel, working different angles, you're more likely to have success more quickly. And that's kind of what happened. But that freaked people out because, it had taken so long before. Why did it take so long now? And and so there's a lot of, like I say, that misinformation. So how do people, understand things where we can have the conversation with them, right? We can get groups together online or wherever it makes sense and just really talk through what's going on.
Yeah.
There's no agenda. We don't have an agenda.
Exactly. You're scientists.
We're science education folks even, right? We're just teaching people what's going on. We don't have a stake. Well, we have a stake in everyone being healthy. Absolutely. But it's really just this idea of saying, how do you create a space where people can really have meaningful conversation? And that's the kind of thing that makes a huge difference, right? Having a conversation with someone as opposed to, well, I read somewhere that, or I read online. Okay, if you start, I read online, let's put that aside. That's not necessarily imprimatur of
it's not
of knowledge.
Twitter isn't where you're going to find the answer.
Yeah, exactly. Well, it might. It's just somewhere in the billions of tweets that are out there.
And just like you said before about humans, messing up a little bit, then you start bringing politics into science. And then it's this big thing. And it's like, okay, well, we need to focus back on, and I talk to people about, we need to focus on what do we know and what do we not know. So, we don't know certain things. Okay, it's fine. We will eventually find out, in the future. But base your decision off of what we know now. What do we know? What are the scientists saying? How are and like you said, like it's only a small group of people before. If we got a lot more people going for it, we're obviously going to find the answer a little bit quicker.
Right.
Which is real. And like you said, it goes right back to that little dot. It goes right back. You look and you see all the answers, and a doctor will see, okay, well, this, that's why it's working. And then you look in and you're like, that's just a dot. What are you talking about? Like, that makes no sense.
Right.
Well, going on a question that I had for you before, when you worked for the museum and traveling, what do you? So, what's one of your favorite stories about traveling? What would you go for? Like, what's a cool event that you did?
I've had lots of bizarre travel experiences, aside from being delayed in many cities. So you want an oh my gosh story or a scary story?
I would love both. Honestly, these are cool.
Okay, so,
I love these.
We'll start with the scary story. Scary story. I was working in Kansas City in the Science Museum there, and I was going to take my very first trip to LA. I'd never been there before for a conference. So this was during the days when you had travel agents, and they set everything up for us. Again, back in the oldie times, I got on my wooden horse, and they pulled me. No, so I got on a plane, and so the way the flights worked, I had to fly from Kansas City east to Memphis, and from Memphis to get a plane to LA. Why? I don't know, because that's how the travel agents set it up. So that meant when I left in the afternoon in Kansas City, by the time I got to LA, it was probably 1:30 in the morning. And it's late, and so I've got this hotel. So I go and I get a cab, and I say, okay, I'd like to go to, I can't remember what it was, 347, let's say, Western Street. And the cabbie is I don't know if he was Chinese. I think he was Chinese. Turns around and says, "You go to Western Street." I go, "Yes, Western Street, Western Street, Western Street." We go back and forth. His accent is very thick. Right? He's saying Western Street, and I say Western Street. Okay, so we take off. We go back and forth for a while. He takes off and he's driving. If you've ever been to LA, the LA airport is quite a ways from downtown, right? So you're driving and driving and driving, and it's probably 2 in the morning now. As you get off the plane, you get the cab and all that. So it's 2 in the morning. But remember, for me, I'm 2 hours ahead. So it's actually 4 in the morning, and I haven't slept because the flights were not overnight flights. It's just I lost all those hours. So I'm trying to stay awake, but I'm so tired. And he's driving. We pass the site that will eventually be the California Science Center. He's driving. And eventually I'm looking around, and we're in this neighborhood that's like, okay, you don't want to stop here.
Yeah.
Right? It's sort of boarded up houses and shells of things. Like there's nothing is moving. Yeah, it's 2:30 in the morning, but nothing is moving. Like not even the rats are out into space. And he slows down and he pulls up next to this row home that's literally a burnt out shell. There's nothing there.
Oh my
It's
God.
pitch black. There are boarded up windows everywhere. Like this is something where like this is not, no one's going there.
Yeah.
Right? This is something where, this is, yeah. It's just, I'm thinking, well, where are we? He says, well, here you are. I'm like, no, what are you kidding me? It's a hotel. It's not a hotel. No, this is it. Western Street. I said, Western. I'm like, what? We're going back and forth. And I look over and I say, we're on West 3rd Street. So he's saying West 3rd Street.
Oh my God.
I'm saying Western Street, right? And we're saying this right past each other, this idea of communication.
Yeah.
Okay. Thank goodness he clears up. Oh, okay. Thank goodness. I'm so relieved that I'm not trapped in LA at 2:30 in the morning with no place to go. So he takes me and drives me finally, and he pulls me up to this Best Western. I'm like, okay, great. Best Western Motel.
Yeah.
Right. And it's got the little house in the front where you check in, and then behind it is a parking lot, and around it in a U are, just 2 stories, motel, drive up kind of thing. And I get out and thank the cabbie, and I go in, and it's this weird heat wave in LA. So it's night, but it's still like 87 degrees, and it's super humid. And I walk in, and there's this air conditioning rattling there, and the guy behind the desk is like 400 pounds, bald, white sleeveless T-shirt with giant pit stains under it, with a chewed off cigar in his mouth. Going, what do you want? And I said, I'm checking in. So he gives me the key and says, well, the air conditioning doesn't work. Oh, great. I'm like, fine. I don't care. I'm so tired. I just want to go to bed. So it's probably about 3 in the morning now. So I leave the little check-in house and I go across the parking lot. And it's weird because for 3 in the morning, the parking lot is hopping. So one entire wing has doors open and cars parked in front, people sitting on the cars, and people are driving up and parking, getting out of the car, talking to someone, connecting with a young lady, and going into the rooms.
Oh my God.
There are other cars pulling up and don't park their car, but pull up, people come over, they have a chat, they shake hands, and the car drives away.
Oh my God.
Right? And there are these, again, more large people with various colors, of bandanas and stuff looking at me like, what are you doing here? And I'm thinking, I don't know. And I go to the room, which is in the catty corner from this. I'm thinking, oh, great. So I open the door, close the door. It's like a sauna in the room. And I'm thinking, you know what? I'm not going to open the windows. I'm just going to leave it here. Let's just go to sleep. A couple hours of sleep, and I'll get up and I'll figure this out.
Yeah.
So I go and I pull the bed sheet down, and right at the head is a giant, not on the mattress, but on the box spring below, because the mattress is like a mattress with just a folded sheet around it, and you could see the box spring underneath it, is a giant red-brown stain right where someone's, let's just say, head might have been at one point in time. I mean, very clear, like, okay, I ain't no biologist, but that does not look good. So I cover up the bed, I take a chair, I jam it up under the door handle, and I kind of sleep with my back to the door.
Oh my God.
In this hotel. And I finally gets to the next morning, and I'm just like, okay, get up. The sun's up. It's probably 6:37, so I got maybe 2 hours of sleep. And I figure I'll just go grab a shower. I open the shower stall door, and it's just a tiny, maybe 2x2 square with a pipe coming out and I guess sort of a shower head. And on the floor is a piece of linoleum, not like linoleum attached to the floor. Like someone had taken a piece of linoleum and put it on top of something. Yeah. Just loose with a hole cut in it. And you can see the drain below it. I'm thinking, I'll wait to shower. I get up, I go to the front desk. I'm checking out. I'm like, they could care less. They call me a cab. A what? A cab. Okay. So we finally go through a conversation and the cab pulls up. Thank goodness. I throw my bags in. I get in the car. I tell him I'm going to the convention center. He turns around. The cabbie turns around, looks and goes, "Did you stay there last night? What are you, crazy?
Oh my God.
This is like the major drug thoroughfare in LA. This is like, oh my God, are you kidding me?" So apparently I spent the night in a hotel that was being used for all sorts of wonderful things.
Oh my God.
Not a beach to sleep. But I did. I got to the hotel, and all the hotels are sold out. So I finally found something. But basically, spent the first 4 hours on a payphone, because again, payphones. That's the time. Finding a hotel out in Pasadena that I could finally stay at for the rest of the conference. But yeah, travel agent. I had some words for the travel agent.
Yeah, that was not the best place to stay. Not
perhaps the best way to set this up. But,
oh my God.
Yeah. So
wow.
So that was my experience. That was my introduction to LA.
First time in LA, and now you're living in Cali now.
That's right. Now I'm living in Southern California.
Wow. Right? Well, at least you now know the area a little bit better.
Yeah, exactly. Well, and again, I don't even know. Was it West Third? Was I in West Turn? I don't know where it was. It was so long ago. I was like, but yeah, it was quite something.
Well, it's the same. I feel like in any big city, you think about New York, same thing. You go on the wrong street, wrong turn. Right. You're not going to the right area.
Right. It's just like, okay, here's where things are happening. At the same time, I'm looking and thinking, okay, so here was this, 20-year-old white kid walking around with a big bag. No one could have cared less that I was there.
Yeah.
I was afraid of what? Well, they had business to attend to.
Yeah, they were.
I was
busy.
the least of their concerns.
I feel like they were more in awe than anything. They were just like, why?
I don't know about that. I don't know about that. Yeah, they're thinking sucker. So I wouldn't stay there if I couldn't.
So what's your best cool story? Cool story. Oh my God.
Oh, so I had we were doing with a museum and a couple other groups doing this. We went to this trip to Russia to see if we could put together an exhibit on Russian history.
Yeah.
Right. So really cool stuff. And the trip was supposed to start, and the first day out, we were supposed to leave the 30th of October, right before Halloween, and be there, and they were going to be there, I don't know, 6-7 days. I said, well, I can't go. My kids are young. I'm not going to miss Halloween. So I'll come out the day after. So the rest of the group had gone out there. So I fly out on my own, and I fly, and you fly through Frankfurt, from Philadelphia to Frankfurt, and then on to Moscow. And it's the same kind of thing. It's an overnight flight, but not quite overnight. So I never really, and I didn't do at that time much international traveling. So I just, I was just kind of up, because you land in Frankfurt and you got a couple hours there, but not enough to sleep, and then you get on the other plane and you're in Moscow. So I'm all screwed up time wise. It's probably, I don't know, probably afternoon, 3 o'clock or something in Moscow time when I got there.
Yeah.
So I'm really bleary eyed. I'm still wearing the clothes I wore to work, I guess a day and a half before, and had been on the plane. And I get off the plane, and there's this little Russian guy with a sign that says Snyder. And I walk up and I point to him, and he says, "You're Snyder?" "Yes." "Oh, come with me." Just real gruff. I'm like, okay. And so we get in the car. He sticks me in the back of a van, and he starts driving off. And I'm like, I don't know what's going on, because he hasn't said more than 2 words or where we're going. And all I'm thinking is, okay, glasnost has happened. This is all good. We're friends now. I don't have to worry about the KGB. But I'm just tired, and we're driving. It's a long drive, but you wind through from the airport. It must have been about a half hour through these white birch forests. So it's literally just nothing but white birch, all you can see. Very, very Anna Karenina kind of stuff that you're driving through. And we hit Moscow, we hit Moscow traffic. I've never been in traffic like that. Like
Really?
An hour to go half a mile. Just insane. And finally, we pull up to this giant government building. I think we're going to the hotel, but no, it's this giant stone, very sort of communist era, with big statues of imposing people and guards with, AK-47s or whatever the appropriate Russian rifle is there in the full uniform. And he pulls up and he stops there and he gets on the phone and he talks Russian. And he keeps looking back at me, Russian. I'm like, what is going on? What in the world is happening? And he says, you go now. You go.
Oh, God.
That's all he says. And so, okay, I grab my bags and I get out and I go up the steps of the building and someone comes out to meet me and says, oh, okay, he's one of the attachés. And the rest of my group is upstairs meeting with the Russian foreign minister for culture or something.
Yeah.
Okay, great. So we go upstairs. I put my bags down. We sit down. They give tea. And the Russian ambassador or the Russian minister is, again, huge guy, just enormous, very stereotypical Russian in that way. And they're talking niceties or whatever about what the next, the museums we'll be seeing next and how this might work and what kind of things we need to go through to get the exhibit going. And all I can do is just try to stay awake and be polite because I'm just dying. So we get done with that and we all load into the back of a van and start driving. And I'm thinking, okay, dinner, because I'm starving and I'm tired. Starving. And we're driving through Moscow traffic again. And I don't know where we're going, but people are chatting about their day. And I'm thinking, okay, we're going back to the hotel and we'll get some dinner. And we pull up in from this other kind of nondescript building. And everyone gets out and I get out. I'm like, okay, it's not the hotel. Oh, please let there be food. And we go in and there's security that checks us out and pats us down. And we go into this little antechamber and this woman comes out and speaks Russian to one of the folks who are working with us and speaks Russian to them. And we're moved into this conference room, big, boardroom table. And we sit down. And I just sit down, try and stay awake. And finally, after a couple of minutes, the door opens and Mikhail Gorbachev walks in.
Wow.
So and there he is, Mikhail Gorbachev, the big red splotch, the whole bit.
Oh, my God.
Walks in and sits down, and through a translator, he starts talking to him. So we basically have a meeting with Mikhail Gorbachev because the guy who had set up the exhibit, or was trying to set up the exhibit, basically ran a speaker bureau. And Mikhail Gorbachev was one of his clients. And so while we were there, we stopped to see Mikhail Gorbachev. And so we're having his conversation. We're having tea with Mikhail Gorbachev.
Oh, my God.
And then he gets us up and through the translator says, you want to see my museum? And he walks us through his museum. And here's his Nobel Prize. And here's the suit he wore where he was kidnapped. Because I don't know if you remember, but he was kidnapped during this whole transition and change in Russia. There was a group that kidnapped him. And he's telling us these stories through the translator. And I was like, okay, either this is super cool or I am so tired I'm hallucinating. But we go and we have this, so we have this cool encounter with Mikhail Gorbachev. And then we had, and that was that. And we did the rest of the trip, which was really kind of cool. But the funny thing was then when I got back, and the rest of the trip itself was just amazing things that you got to see. I mean, just incredible stuff. But we got back, we had been running this exhibit at the Franklin on Cleopatra. So I got back and I went into work, and I'm in work that first day, and they got a call, said, Steve, would you be able to give a tour of Cleopatra, the exhibit? I said, sure, okay, that's fine. I come upstairs, and what I didn't realize at the time was the American Museum of Jewish History was going to open that weekend in Philadelphia, brand new facility. And so I walk up, and here's who I'm giving a tour to, and there's Barbra Streisand.
Wait, so you're just meeting all of these famous people?
Exactly.
Oh my God!
It was just what in the world? So there's there she is, right? There's Barbra Streisand sitting there. She apparently is a Cleopatra nut. So I gave a private tour of the Cleopatra exhibit to Barbra Streisand, who was in town for this thing. And again, like everything else, people have their public image and everything, but just a lovely, sweet woman, at least as far as the tour was concerned.
Of course,
asking good questions and just very quiet and all that, and so I gave this tour to her after that, and I said, okay, that's probably enough famous people for me. So Mikhail Gorbachev and Barbra Streisand. I don't know how the two fit together, but somehow they did.
But still, the fact that you're just meeting these random people that are just like huge famous guys.
Well, yeah, and it's the strangest thing. So I run into other ones as well. So obviously there I got a chance because we did an awards program to meet Bill Gates. When we did our Body Worlds exhibit, I was working late one night, and I just had a habit of kind of walking through the exhibition, at the end of the day to see how everything was holding up. And as I'm walking through, here comes this young kid and this little wrinkled man walking behind him. And I stop and say, "That's not a wrinkled man. That's frickin' Mick Jagger."
Like what?
And there's Mick Jagger and his son going through the Body Worlds exhibit. I guess he had a concert in Philly. So you have these kind of moments where you're just kind of like, okay.
So in your industry, you're just meeting famous people out of nowhere. I mean,
well, you work long enough in enough different spaces, and weird things happen.
You're gonna run into some
really
cool
interesting people from time to time. You get to meet a lot of, like I say, in my job, I got to meet a lot of interesting people, including interesting people who weren't famous. I mean, people who worked in museums who had these incredible stories, or just all sorts of kind of cool stuff that I had the chance to do.
Well, that's why I like the podcast. This is why I like this, is because I get to talk to you. I get to talk to people who've lived interesting lives. I mean, just right off the bat, you have this interesting life that nobody could. You're going and meeting Gorbachev. You're meeting Barbra Streisand and having like these cool experiences teaching people. And your field, one thing I wanted to ask you, what is your favorite? I'll ask the current one you're at too. What was your favorite part of the Franklin Institute, and what's your favorite now of your current institute?
Oh, that's like saying which is your favorite kid, right? You really can't say that publicly. And I'll tell you, my favorite one is whatever is the next one. That's always
that is an awesome answer, because they're always so cool. Every time I went, the Galileo one I loved, King Tut one I loved. One of my favorite things at the Franklin Institute that I never did, and I'm still terrified to do, is that one, the bike that goes across the museum.
The high wire bike, yeah.
Oh my God. And I remember as a kid, I said I was scared of it, and you're like, okay. And you hopped on and just went backwards and forwards. Like, why is that one there? Like, is there like a meaning behind that as well?
Yeah. I mean, high wire bike is actually an example of center of mass. You can't fall off it. It's
like
physically
how,
impossible.
Though?
So it's basically at the bottom of, so you're on the bike, it's on a high wire, and it's like a 2-inch metal cable, 'cause it's got to hold you up.
Yeah.
But then the bike is attached underneath to a weight, a counterweight on the bottom. So for you to fall off, you would have to weigh, 400 pounds or so to get that counterweight up high enough for you to fall off. Obviously, you're strapped into the bike, but for the bike to fall off, the counterweight would have to go all the way. And you'd have to be way heavier than someone would normally be to be able to actually knock it off.
That's so interesting.
So it keeps it stable.
That's so interesting. Yeah, like looking back, some of my fondest memories is going there with my cousins and seeing you and going into the exhibits and sometimes getting a little bit of early access and stuff like that. That was my favorite stuff. But thank you so much for coming on the show. I know this was last minute, but I know that you were in town, and I haven't seen you in
it's been a long
so
time.
long. But thank you so much.
Sure.
Guys. Steve Snyder, is there anything else you'd like to say about your promote about your museum or your institute?
Oh, no. Hey, if you're in San Diego, you come down to Balboa Park, come to the Fleet Science
I have to get over my fear of planes, but I definitely want to go to Cali. All right. Thank you so much, guys. All right.